Well, today we're going to be talking about AC circuits. So right here we have a smart physics circuit problem with just an interactive example. We have an AC circuit base. We know that the inductance is 24 millihenries, the capacitance is 40 microfarads. R is unknown. We know the maximum generator voltage is 120 volts and the maximum current is 1.4 amps. Now the key also to this problem is that they give us the frequency, so that means you can calculate omega right away, because as you can recall, omega equals 2 pi f, so that means omega equals 620 pi. Okay, so we're asked to find what is the phase angle. Well, generally the first approach that I like to take with these problems is I like to find the resistance in the capacitor and the inductor, and as you know, XL, resistance in the inductor, is equal to omega L, and you know that XC equals 1 over omega C. Okay, we know W, we know L, so we can immediately find these right away. And this is how I always like to set these problems up. If inductance is given and the capacitance is given, then we can create a phase diagram pretty easily. So let's find these values right now. So this equals 620 times 24 times 10 to the negative third henries, just to be in standard units. So if I get my handy dandy calculator out here, so we are looking at 620 pi times 24 times 10 to the negative third, which this equals about roughly 46.7. This equals 1 over this equals about 12.835. Now, since we know that the resistance through the inductor is greater than the resistance through the capacitor, we know that the voltage will lead the current in the phase diagram. So if the voltage leads the current, we can start drawing our phase diagram, which this is what I do for my axis. This is a dotted line. Okay, we know Emax is right here on this line. Okay, so if the voltage leads the current, then we know that the current is going to be below, right about here. Okay, and this is true because since the resistance through the inductor is greater than the resistance in the capacitor, then we have this projection line right here, which is going to be Imax times XL minus XC, and as you can see, XL is greater, so you're going to get this vector that points to the maximum generator voltage, and we know that this equals IMR, just the maximum current and the resistor there. Okay, we're asked to find phi. Okay, we don't know R, but we know Imax, we know Emax, and we know a value for each of these. Here's our angle phi. So we can calculate phi right away. As you know, this is a 90-degree angle, so we know that sine of phi equals Imax XL minus XC all over Emax. So if you take the sine inverse of this, so phi equals sine inverse Imax XL minus XC all over Emax, which, if we evaluate that, we will get roughly 23.307 degrees. And on smart physics it says define phi to be positive if the voltage leads the current. Well, we know the voltage leads the current because XL is greater than XC, so positive. And that is your final answer for the interactive example. Thanks for watching.